All right, today with our ionic compounds, naming ionic compounds. Yesterday we worked a little bit about writing formulas. Today we're going to work it the other way. We're going to be given a formula and we're going to write the name for it. Once again, we're talking about binary ionic compounds, but I got a feeling here we might, since we got polyatomics in there, we might have more than just two elements. So it might be more than binary, but we'll see here coming up. Okay, learning target, once again, using the chemical formula. Write the name of the chemical compound. So you will be given the formula and you should be able to write the name of the compound. What do we need to do to be successful with that learning target? Well, number one is identify multivalent ions. We did that yesterday, so hopefully that's just a little bit of a review. Okay, since we're talking about multivalence, we might as well get our periodic tables out now because we're going to be needing those. All right, let's see where we're at. Maya, how can you tell whether something is multivalent? You look, excellent. You look at the oxidation state. Okay, the little black number on top of the symbol. If there is more than one, it is multivalent. Also remember, when we were dealing with the nonmetals, all right, they have more than one above them a lot of the times. However, those nonmetals, when they are gaining electrons, only take a single charge. For instance, check out chlorine. How many oxidation states are above chlorine? A bundle of them, right? Okay. But what charge does chlorine take when it is forming an ion? -1. Good. -1 because it wants to gain one electron to fill its outermost energy level. We need to be able to use the stock system of naming. Now we're giving those Roman numerals a name. It's the stock system. Okay? Stock system is Roman numerals. We need to be able to name and write formulas using polyatomics. Our pal is going to be our friend here, our polyatomic ion list. And finally, we need to be able to name ionic compounds. So let's get started. Multivalent. Some elements can form two or more cations with different charges. Notice that it says cations, people. Cations. So we are dealing with metals. That's why I said don't worry about all those little numbers above chlorine. It's a nonmetal. Okay, when we're talking about multivalent ions, we are talking about metals. We talked about looking at the oxidation states, so I think we're all right with that. Iron, okay? Iron takes an oxidation state of 2. Iron takes an oxidation state of 3. Iron takes an oxidation state of 6. Remember that, ladies and gentlemen, because you're going to see this coming up if it wasn't on last night's video. It asked about the states of iron. Now, your periodic table probably only has 2 and 3, doesn't it? Okay. Remember that sometimes 6 is in there also. Iridium. Look at iridium on your periodic table. IR. I'm looking there. This one up here has 4, 2, 6, 3. Okay? And there we are. So it has 4 different oxidation states. So iridium could have the ion +2, +3, +4, or +6. The stock system uses Roman numerals to indicate the ion's charge. The numeral is enclosed in parentheses and is immediately after the metal. So if we would have iridium, parentheses, IV, IV is the 4, so that would have told you that that was iridium. The ion's charge would be 4 plus. Iron 2, iron 3, iron 4, or excuse me, iron 6. All right, VI, 5 and 1, 6. So those Roman numerals in the parentheses are what we call the stock system of nomenclature. Here's lead. Look at lead. We dealt with him yesterday. What, Drake, are the charges lead can have? 2 and 4. So here's lead 2. Here's lead 4. I get those arrows in there. Latin names. Take out your ion sheet. Okay? Take out your ion sheet. And on the very front page of that ion sheet, down at the bottom, you have common names, or excuse me, you have stock system names, and this calls it the classical system, where Romaro was talking about the OUS and the IC endings down at the bottom. So you can see different things like, okay, the OUS ending there on the very right-hand column of that. So these Latin names are older, depreciated notation that has an OUS or an IC added on to the root of the Latin name. OUS is the smaller of the two. IC is the greater of the two. So when we see something like Auric or Aurus, okay, these Latin words are why many of these symbols don't make sense. Why is iron Fe? Why is lead Pb? Why is gold Au? Well, those symbols are coming from the Latin words. So Aurus in Latin is gold, so that's where we get the Au. So if you look at gold on your periodic table, okay, let's check out gold on our periodic table. If we see it can take a 1 and a what? 3 by the oxidation states, right? So we have Rus is the smaller one because the OUS ending. Auric is the larger one. Plumbic, plumbus. Lead can take, Drake said, it can take a 2 or 4. So plumbus is lead 2. Plumbic is lead 4. Now, the final thing we're going to discuss today, before we get into some naming formulas, are polyatomic ions. When naming compounds, the most common polyatomic ion is given the ending ATE. If we take one oxygen off of that, it will give us the ITE. So the most common one, ATE, subtracting the oxygen gives us the ITE. NO2 is nitrite. Is that the most common one? No, because it doesn't have the ATE ending. Okay? Based on those rules, if nitrite is one less oxygen, nitrate is going to be NO3, -1 charge. So that is the nitrate ion. Sometimes two elements form more than two different anions. In this case, we use an anion with one less oxygen is the ite anion. One less oxygen than that, we put hypo in front of it. An anion with one more oxygen than the ATE is given the prefix per. Now, how I remember these are with the chlorates. Okay, so on your ion sheet, turn to the second page. Okay, turn to the second page, and I want you to find chlorate. Okay, the actual second page, not, go to the PAL list. Let me be more specific. Go to the PAL list. Find chlorate, because all of these are going to be right in a row there. You will see chlorate. Right under chlorate is perchlorate. Right over chlorate is chlorite. Right over chlorite is hypochlorite. How do they differ? By one oxygen. So just remember those chlorites, and you remember everything. So look up on the board here. We're talking chlorate right here. If I take one oxygen away, it is chlorite. So ClO3 minus 1 is chlorate. Take one oxygen away, ClO2 minus 1. If I take chlorate and add one oxygen, it's perchlorate. Perchlorate. If I take chlorite and minus one oxygen, it's hypochlorite. So look, and I want you to find bromate on your PAL. Find bromate on your PAL. Is he on there? Yeah, it's right above hypochlorite, right? Bromate is BRO 3 minus 1, correct? What would bromite be? Ashton? BRO2, what charge? Negative. Okay? So we just take away an oxygen. What would perbromate be? Paige? BRO4, 1 minus. We add one oxygen to it. Okay? What would hypobromite be? Ella, what do you think? BRO 1 minus, right? So if you just look, because the reason I use these chlorites and chlorate, because they're all right in a row on the PAL. So you've got a visual right there that you can see it. Okay, because you're going to see sometimes on WebAssign that they're going to have a polyatomic that's not on your list. Now, you got a bunch of them on the list. There's a bunch of them on the page before it, and I think there's a bunch on them on the back page, right? So you have all kinds of polyatomics on there. But every once in a while, we're going to run into some that are not on our list. Okay? If that's the case, think of this slide right here. Can I add or subtract an oxygen and get the ion? Now, when we name a binary ionic compound and we need to use the stock system, I have certain things that I go through, kind of a mental checklist here, okay? So, when I'm going through this particular one, CuCl2, I know I'm dealing with copper, I know I'm dealing with chloride. So, what I do is I get the name of the cation. I get the name of the anion, and I see if I need a Roman numeral. So what is the name of the cation in this specific instance? Let's start back here with Will. What is my cation?
It's copper chloride.
Okay, the cation's only got to be one of them. Just copper. The cation is the first one. Remember that we write the metal first. So the cation is the first one. Will says it's copper. I have copper. Let me get to where I need to be. Okay, I have copper there. The name of the anion then is what, Kaylin? Chloride. Remember, not chlorine. The ion is chloride. Now, I have copper, I have chloride. I need to check every time to see if it's multivalent. Is copper multivalent? Mackenzie? Yes, it is. Great. How can you tell copper's multivalent? It has two oxidation states, and what are they? +1 and +2. So now we have to decide which copper we have. Copper 1 or copper 2. Now, I let the cat out of the bag because I clicked one too far, if you would have paid attention there. All right? How do I tell which copper it is? I need to look at chlorine. Okay? Look at the chloride. We know what charge chloride is, don't we? What is chloride? Okay? Total charge, right? What is it by itself? By itself, chlorine is -1. But I have two of them, right? So I know that my total negative charge is 2, right? So to get a net zero, my copper's got to be 2. That's why we have copper 2 chloride. Now, if I would have just put copper chloride, would I have been right? No, because I wouldn't have signified which copper it was. I need to say which copper I have. In this case, copper 2. Now, we're going to look at some of these, okay? And we're going to name some of these, starting off with KOH. All right? We're going to go through the process. I look and I say, okay, here is my cation, K. Here is OH. That is a polyatomic anion, OH. So, as I'm looking at this, let's go through my steps. Romaro, what is my cation? Potassium. So, I'm going to write down potassium. Maya, is potassium multivalent? It is not. So do I need a Roman numeral? I do not. What if I would put a Roman numeral? It's wrong. Okay? I do not need a Roman numeral. So I do not put one. What, Ashton, what is OH? You got a pal. You got a pal, right? You're absolutely correct, but double check your pal. Okay? Because you seem like you were a little bit unsure of yourself. Is it? It is hydroxide. Okay? So, I've got potassium. I find OH on my pal. And I write hydroxide. Am I done? Yeah, I'm done. Fe, F3. Drake, what is my cation? Fe, which is what? Can't hear you. Iron. Good. Is iron, Paige, is iron multivalent? Yes, it is. So what does that tell you? I need a Roman numeral. So I'm just going to put my parentheses in right now To remind myself I need a Roman numeral. It's multivalent. Okay? Ella, what is my anion? Fluoride. Excellent. For a minute there, it must have been the mask. I thought you said fluorine, but it was probably fluoride all along, right? Now, let me tell you something about this guy. Let me tell you something about this guy. I've seen more people miss this on WebAssign because they spell fluoride wrong. They spell flower-eyed. They switch the O and the U. Okay? And WebAssign will count you wrong for that. So don't do that. We've had some times where we're sitting there and we're trying to figure out why it's wrong, and then all of a sudden it's spelled wrong. Fluoride, F-L-U-O-R-I-D-E. Now, once again, make sure you get the O and the U right because it'll count it wrong. Now I need to go back and figure out my Roman numeral. Okay? What charge is the fluoride ion? Okay? What charge does it take? Not how many are up there. What charge does the fluoride ion take, Will? -1. And how many of those do I have, Will? Just that one? Yes. I have 3 fluorides. Excellent. I have 3 fluorides. So what iron must I be dealing with here? Iron 3. So I'm going to put 1, 2, 3 as my Roman numeral. Iron 3 fluoride. Here we go again. I got some new stuff here. I've got parentheses there, don't I? So parentheses tell me I'm dealing with a polyatomic that has more than 1. All right. Kaylin, what is my anion? Excuse me, check. Give me my cation first. My bad. 10. SN is 10. Is 10 multivalent, Kaylin? Yeah, it is. So what's that tell me? I'm going to need a Roman numeral. So I'm going to put my parentheses there. Mackenzie, what's NO3? Nitrate. Did you look at your pal? Okay, it is nitrate. Is that the most common one? Yeah, how can you tell, Romaro? The ATE tells me it's the most common of that particular polyatomic. Now, when Mackenzie looked up the nitrate ion, what was its charge? What was it, Mackenzie? -1, right? How many do we have up here, Maya? How many nitrates do we have? Here's nitrate, right? Let me walk you through it. There's nitrate, right? How many of those do we have? We have 2 of them, right? So if it's -1, what's the charge, my negative charge I got? -2, right? If I have 2 of them and nitrate's -1, it's -2. So what must my charge for 10 be? Must be 2, right? So I'm going to put Roman numeral 2 there. Now, this one I put on there. I was going to have you do one by yourself, but I'm going to walk you through this one too. All right, Ella, yeah. Are you going to have to put Roman numerals in WebAssign? Absolutely. There'll be I's. Yes. Capital I's. Okay. We'll talk about some stuff on WebAssign here. Maybe I'll bring that up because I'll give you some pointers on WebAssign on a couple slides here, all right? But nonetheless, they are capital I's, okay? I've seen it too. People put lowercase l's. Yeah, and you and I can't see the difference because of the font, but WebAssign can because it's a computer. All right, right here. Look at this guy right here where this little red dot is up here. NH4. I want you to find him on your PAL. Can you find him? Well, you're not looking very good. It's the very top one on the left. Okay? The very first one you see. This ammonium. Ammonium is just something you're going to be familiar with. It's all right, let's look back up here at this this NH4. NH4 is the ammonium ion. Okay, so that is ammonium. SO4. What is SO4, Drake? Sulfate. Now, with ammonium here, you will never have a Roman numeral with ammonium. I see a lot of people, since there are two ammoniums up there, they want to put a Roman numeral 2 behind it. No dice. No dice. You do not need a Roman numeral with ammonium. So, basically, NH4 parentheses 2, SO4 is ammonium sulfate. Two polyatomic ions connected together as a compound. Questions about that? You just have to recognize when that NH4 comes up that you have ammonia. And like I said, we only have a couple polyatomic ions that are positive. Ammonia is one. We're going to talk about later on when we do acids and bases. We're going to talk about the hydronium ion. Okay, but we don't hardly see that with this naming stuff ever. Now, my next slide here. Okay, my next slide here is some WebAssign things. All right, and go ahead and write these down in your notes. That way, when you come up to me and complain because they counted you wrong, because you wrote it wrong, I can say, we wrote this down on our notes. We already talked about that. I told you not to do that. So, if I have FeF3, we simply write it as FeF3 because we cannot get this 3 right here. We cannot get that as a subscript on WebAssign. So we just put it right beside it. The same thing with down here. We cannot get the subscripts, so we don't write them as subscripts. We just write them on the direct line. Now, if you're handwriting this, is this acceptable? No, it is not acceptable if you are handwriting this. This is only acceptable when we're using WebAssign. Something else about WebAssign. Do not use capital letters when writing the names of formulas. That was a nice choppy sentence, huh? Do not use capital letters when writing the names of formulas. Do not use capital letters. WebAssign counts those wrong. I have told you. I've said it 3 times. Here's the 4th. Do not use capital letters when writing the names of formulas. WebAssign will count it wrong. Okay? I'm not going to feel bad when you come up and say WebAssign counted this wrong and I think it's right. And I said, nope, use capital letters. I told you not to. All right? So do not use capital letters. Any questions for me about naming or writing the formulas of binary compounds? Got a thumbs up for me? We ready to get at it? Because you're getting at it next period. Thumbs up, Will? All right.